Greetings, liberal arts math students. I am missing you, but hopefully we're doing well in Texas, representing all of FLA proudly and bringing back another championship, or at least doing our best to do so. Hopefully you guys are doing okay. What I wanted to do is go over the next lesson of probability. This should be done for you on Thursday. I don't want things to have gaps missing, so we can keep moving along at a measured pace, okay? So this is in your book, it's 7.4. 7.4, it's called Addition and Multiplication Rules of Probability. And in actuality, this stuff isn't that bad. I've already certified myself over the weekend, so I'm prepared to show you what to do. So I'm going to go through, obviously I'm going to go through whatever problems I can find that come through. You may come up with a couple of additional ones that are not going to be what I'm showing today. Help each other out, because again, I think you guys can handle this section, especially for practice, until I get back with you on Monday, okay? So what I'm going to do is go through this together with you now. I do want to tell you a joke, of course. It wouldn't be life with Dr. J if there wasn't some great and awesome humorous joke to go along with it. This joke I love because it actually combines my two favorite things I tell you, the dad jokes and the poop story of the day. Some of you may know what the euphemism we use in America sometimes for toilets is. It's a male's name, and that is a John, right? We call it, I gotta go to the John, we might say. Well, I've made a decision. I'm gonna call mine Jim instead of John. That way every morning when I see you guys in class, I can say, hey guys, I went to the gym today, and you all will be very impressed. All right, it's the best I can do. All right, so off we go. I'll read the problem to you and then we'll work through it, okay? So this one says, a single letter from the word additionally is chosen. What is the probability of choosing an A or an I? Express your answer as a fraction in lowest terms or a decimal rounded to the nearest millionth. A reminder, if you round it to the decimal to the nearest millionth, that is 6 places after the decimal, okay? So this is very straightforward. It'll be when you guys pull up your work, it'll be some other word, almost certainly. But all you do, count the total letters. Remember, probability is desired outcomes over total possibilities. Okay, desired outcomes over total possibilities. So, in this word additionally, it's asking what is the probability if we had those as little letters in a bag and we chose one tile out of it. Like we had a Scrabble game, we threw the Scrabble letters in a bag that spelled the word additionally. What is the probability of choosing either an A or an I? All you do is count how many A's and I's are in the word first. So 1, 2, 3, 4. There's 2 A's, there's 2 I's. There's a total of 4 desired outcomes. The total possibilities, you just count the total letters in the word. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So total possible is 12. 4 over 12. Remember, you always reduce. This becomes 1/4. 1/3, sorry. Let's see if I can do my math correctly this morning. 4 goes into 12 3 times. So I'm going to put that in. 1 over 3. Submit. Great. Easy. Select all of the situations that contain independent events. In probabilities, something is considered an independent event if, what this looks at is you're doing maybe two different things, 2 or more things to determine what the probability of something is happening. If whatever you're doing is not related to the other thing, then they are considered independent events. If one thing affects the other one's probability, they are now dependent events. So, in this question, you are to select every option that is an independent event. The first one says, pulling a red marble from a jar, and then pulling a second red marble from a jar without replacing the first one. So you've got a jar of marbles, different colors, including some with red. You pull one out, you want to pull out a red one, you set it down, then you reach in, pull out another one to see if you get another red one. Independent or dependent? Does the one first thing I did affect the probability of the second one? The answer is yes, it does. Because if you don't replace that marble back in there, you've reduced the total number of red marbles and the total number of marbles in that mix. So it affects whatever you do after that. So this is not one of our options. Second one says selecting an A and then an S from a pile of face-down lettered tiles without replacing the first tile. So again, we've got a big Scrabble tiles. And you reach in, what is the probability of pulling out an A? You set that tile down, you don't put it back in the mix, then you reach in again, what's the probability of selecting an S? Does one affect the other? It's just like the first one. We did not replace the tile, so the total tiles available went down, which changes our probability. These are not independent events, so nope, no to that. C, eating a candy bar and test results showing a high level of blood sugar in your bloodstream. Well, clearly this is not independent events. One clearly affects the other. This is a very strange option. I'm hoping I'm not wrong. I'm pretty confident that that is definitely not it. And then winning a marathon and winning the lottery. Independent or dependent? Hopefully, clearly you can see that that is independent. One has nothing to do with the other. There's two different probabilities. Winning a marathon. Now listen, it'd be funny if winning a marathon actually improved your chances for winning the lottery. I bet you that America would be a much more healthy place because all of us would be trying to win a marathon. But clearly they're independent. So I believe only the last one, D, is correct. Let's test my theory. Hey, I'm right. Good job. All right, next question. Select all of the situations that contain independent events. Again, looking at them. First one says smoking cigarettes and getting lung cancer. Clearly we know those are dependent events. One affects the other. Next one, drawing an ace and then drawing a spade from a standard deck of cards without replacing the first card you drew. Pretty straightforward here, just like the last group. Anytime you don't replace what you've drawn, it is not independent. It affects the outcome. So when you read these questions, if you replace it and then draw again, it's independent. If you don't replace it, it's dependent. So this is dependent, not one of our options. C, the destinations of 3 randomly selected travelers at an airport. What do you think? I agree. I agree with you, Cecia. These should be independent. The 3 randomly selected travelers, selecting one in no way affects what the other one's outcome is. So I believe this is an option we should choose. And finally, again, winning the marathon and winning the lottery. A repeat of the question. We already said yes, so I'm going to go with C and D. C and D. And we're good. Next question. All right, these are not hard. You just got to be careful with your additions. You have this table. This table says these are students on the student government board. You've got freshmen through seniors plus graduate students. Those are students that are getting their masters and such. They've already gone through what's called undergraduate. Now they're in graduate school. So we've got the next column, those that live on campus in the dorm versus those that live off campus in whatever situation, parents, apartments, whatever, it doesn't matter. So the problem says this: use the following table to find the probability that a randomly chosen member of the student government board is a senior or lives in on-campus housing. Express your answer as a fraction or as a decimal. All right, so what are the odds of, if you have all of these students, say in a bowl with their names on it, you draw one person out. What are the odds that A, it's a senior, or B, they live on campus? Okay, It would have been nicer if they'd given us one more column and one more row and did the totals, but they did not. So what I need to do here, first thing you need to do is how many total options are there? All right? So we've got 2, 6, 9, 10 here. We've got 8, 9, 10, 13 here. Okay? For a total of 23 students altogether. How many seniors do we have? 3 and 1, we have 4. So you're going to be tempted to put 4 out of 23. However, you must do this one thing. One of those 4 lives off campus, which we already have captured here. So you need to reduce this number by 1, because one of them is already in our total of off-campus housing. So we want to choose, here, let me back up, I'm probably confused a little bit. So remember, they're asking what's the probability of a senior, which we said there's 4, or lives on campus, which there are 10. I'm sorry, so it looks like our options are 14 out of 23. 10 on campus plus 4 seniors. However, 3 of those seniors live on campus. We already have captured them in here. So we need to reduce this number by the 3 that already live on campus. So we've added 1 more senior for a total of 11. So our final answer should be 11 over 23. Okay? Again, 10 total on campus, 4 seniors, but 3 of them already are captured here. So it's 10 on campus plus the 1 additional senior that lives off campus for a total of 11 out of our 23 possibilities. Natalie, I'm going to bet you got that better. So if the others are struggling with this, please pause this at this time and go over it again. Next question. Very similar situation. This time, exact same thing. But now we want to check for freshmen or on-campus housing. Let's look at our numbers again. On-campus housing, 3, 5, 6, 9, 10. Off-campus, 3, 4, 6, 7. And this time we're dealing with freshmen. There's a total of 3. Okay, so we've got 3 freshmen total, and it's about on-campus housing. Our total students altogether is 17. So, on campus is 10. We have 3 freshmen. It looks like 13. But all 3 freshmen live on campus. They're already in this number. Okay, so we don't take that into consideration. All we worry about is this, 10 on-campus housing out of 17. That's our probability, 10 out of 17. And just so you all know, that's pretty typical. Freshmen are not allowed to live off campus unless it's with their family. All right. Next. A bag of 13 marbles contains 7 marbles with red, 5 with blue, 5 with green, and 4 with red and green. Okay? That doesn't mean, obviously, that that these 7 marbles only have red, because if you did that way, it looks like we have 12, 17, 21 marbles, but we only have 13. So these 7 marbles with red on them, some of them also have green on them, 4 do. And the 5 with green on them, also some of them have red on them. In fact, 4 of them also have red. Okay, so this question says, what is the probability that a randomly chosen marble has either green or red on it? Express your answer as a fraction. And it says, note these events are not mutually exclusive. In other words, you can have both of them if necessary. So we've got 7 red marbles, it says, 5 green. Of those 7 red, though, 4 of them have red and green. So we have 4, I'm going to call them RGs. And we've got 4 red greens, which means we have an additional 3 that only have red. Because again, a total of 7 have red, so we have 4 red greens and 3 red. Down here we also have 5 green, but 4 of those are under the red-green. So we just have 1 additional green one. 5 minus 4. Okay? That gives us 1 green, so if we draw out a bag of 13 marbles, we have 8 possibilities to get to drawing either a marble that has either red or green, and it could have both. So that's 8 out of 13. Again, pause here if need be. One of you that gets it easily, please help the others. Carolyn, that may be you. I know how much you like to stand up front and talk, but I am going to ask you to do so if you get this, or Natalie, or anybody else that also understands it, okay? Pause here if need be. Next question, another table. All right, here we have survey results on restructuring campus to include an honors college. Who cares? That's just what the table is. The following table shows the breakdown of opinions of faculty and students on this topic. You have some that favor it, some that oppose it, and some that don't care. This has nicely given us the totals, so that's great. So all you need to do here is ask what it is what is our desired outcome. We want either find the probability that a randomly selected person is either in favor of or opposed to the restructuring. Okay? It doesn't care if it's a faculty or a student. It just wants to know if you have a total of, look here, a total of 187 between faculty and students, 187. How many, if you just selected one of those out of the hat, what is the probability that they will either be in for it or against it? Okay? The neutrals we're not factoring in. So that's 74 plus 65, which is 119 out of 187. I don't know if it can be reduced. We're about to find out. So I'm going to put it in just like that and see what it tells me. 119 divided by 187. What the? Says I'm wrong. What did I do? Love that. Okay, let me go back again. Make sure my math is right. That is 119 and 187. Honors fund, that number is either in favor or opposed Got to tell you, don't know why I'm wrong. Is either in favor of or opposed to the restructuring. Oh, bother. Yeah, my math was off. Sorry. It's 139. 74 plus 65 is 139. Love that. All right. Let's fix that. There we go. Next. Another table. Aren't we having fun with tables? Okay. This is his literature class. This is Mr. Weber. I had a teacher named Mr. Weber. Loved him. He wore little spectacles. He was awesome. Anyway, he teaches all 4 classes, freshmen through seniors, males and females broken down. What is the probability that he selects a male only from the juniors? Okay? He's going to select a male randomly from the juniors. So here's our junior class. If you add them together, 6 plus 12, we have 18 total juniors. He wants to select a male from that total. Our total is not everybody because we're only worried about the junior class. So the 75 is deceiving. That is not our total possibilities because we're only talking about the juniors. Our total possibilities are 6 out of 18, which when you reduce it is 1 out of 3. And voila, next. Here's another marbles bag. You've got red, blue, green, and 5 with red and green. What is the probability of choosing either red or green? So again, we have 5 with red and green. We have 6 red, 6 blue, and 5 green. So, of these 6 red, 5 of them also have green. So we only have 1 with only red. Of these 5 green, all 5 also have red. So we have no unique greens. So we have a total of 6 marbles that can give us either red or green when we draw them out of this bag. The total marbles in the bag are 13, so our probability is 6 out of 13. You'll get the hang of this problem pretty quickly as you practice it. Just identify how many have only the one color versus those that have both colors. Another table. All right, so here again, we have favor and oppose, the same type of thing. What is the probability of a selected person is either a faculty member in favor, or a student who has an opinion either for or against it. For is the same as favor, against is opposed. So those are the ones we're concerned about. A faculty member in favor and a student either for or against it. So we add those up. 7 plus 70 is 77, and plus 46 is 123. Unless I've messed up my math like last time, let's hope it's not true. There's a total of 204. Okay, 123 out of 204. I can tell it's divisible by 3. Remember what I said when you add the digits together? 1 plus 2 is 3, 3 plus 3 is 6. So that's divisible by 3. And then 2 plus 4 is 6. So when you divide it by 3 to reduce, this becomes 41. And this becomes 64, if I'm right. 3 to 20, 6, 18, 20. Yeah, 41 out of 64 is our probability. Let's test. Oh, poo. What did I do wrong? What I should do? Let me make sure, first of all, I read it right. Let's make sure I added it right. 77 plus 46 does equal 123, and it tells me there's a total of 204. Person is either a faculty member in favor or a student has an opinion either for or against. So my 123 is correct. Divide by 3 is 41. 204, divide by 3. Ah, there you go. 68. All right, getting old. Let's try that again. 41 out of 68. I'm trying to do this quickly this morning before classes start. There we go. Best. All right. Another table. Just about through. All right, here we go back to Mr. Burke now in his physics class. Miss Sagowski, no, Miss August and her physics class. This time you want to select a male from the sophomores. There's a total of 96 students, who cares? We're only worried about males that are sophomores. Here's our sophomores. There's a total, 9 plus 7 of 16, and there's 9 males. That is not reducible. 9 out of 16 is the answer. 9 divided by 16. There we go. Good job with your math there, Dr. J. Yay! All right. 2 dice are rolled. What is the probability that the sum of the numbers rolled is either 6 or 10? Express your answer as a fraction in lowest terms. All right. So again, desired over total. When you roll 2 dice, each die has an option of 6 choices. You're rolling 2. So your total is 6 choices with the 2 dice. 6 squared equals 36. Okay? So your total outcomes possible are 36 outcomes. When you roll 2 dice, you want to add them up to either 6 or 10. So think about a dice, or 2 dice, when you roll them. What do you need to get a 6? A 1 and a 5 and a 1, a 2 and a 4, a 4 and a 2, and a 3, 3. So to roll 2 dice, there are 5 options to get a sum of 6. Set that aside, there's 5. Now to get a roll of 10, a 4 and a 6, a 6 and a 4, and a 5 out of 5. Okay, there's 3 more. So we had 5 before, plus 3 is 8. 8 out of 36. That can be reduced. They're both divisible by 4. That's 2 out of 9. Okay, 2 times out of 9, when you roll dice, you'll get a sum of 6 or 10. Great. 2 more to go. A swim team consists of 7 boys and 4 girls. A relay team of 4 swimmers is chosen at random from the team members. What is the probability that there are 2 boys on the relay team given there are 2 girls on the relay team? This one's the trickiest of all of them. Okay? So you've got a swim team that has 7 boys and 4 girls. You want to choose 4 of them for a relay team. Well, you've already chosen 2 girls. So you started out with 11 total and dropped it down to 9 total. Alright? So you've got to figure out 2 different things for probability. What is the probability of selecting 2 boys from the 7 divided by 2 boys from the total? You know what? I'm not going to work, we're going to work this out together on Monday, so if you get to this problem, if you can work it out, that's fine. You can miss this one and still get certified, but I want to work it out with you together on Monday. This one's more complex. Honestly, I don't have the time right now to finish this, and I think this is going to be better where you and I can interact together, because this one's a little confusing. So when you get to this one, if you figure it out on your own, that's fine. If not, we'll work on it together. But you can even miss that and still get certified. Just save that in your back pocket. Let me see, I'll skip and go to the last one. 3 cards are drawn with replacement from a standard deck of 52 cards. That means you draw a card, and then you put it back, draw a card, put it back, draw. So you could actually choose the same card 3 times. Very slim odds, which is good. Find the probability the first card will be a spade, the second card will be a red card, and the third card will be a 5 of clubs. Okay? So, our probability of drawing a spade is 26 out of 52 total cards. No, sorry, 13 out of 52. A spade is 1 suit, there's 4 suits, so 13 out of 52, which is a 1/4. Okay? The second card will be a red card. That is 26 out of 52. Okay? Equals 1 out of 26. And then the third card will be the 5 of clubs. That's one option. 1 out of 52. Okay? So, if I'm remembering how to do this correctly, what we do first is multiply your denominators together for your desired outcomes. Okay? 4 times 26 times 52. 4 times 26 times 52 equals 5,408. You're going to divide that by the total possible outcomes. You're going to do 52 cards 3 times. That is 52 cubed. It's a big number. 140, 608. If I'm right, great. If I'm not, don't worry about this. We'll work on it together on Monday, but at least I've got you started. 140, 608. So I'm thinking it's 0.03, let's see. 0.038 462. 1, 2, 3, 4, 5, 6.0. Let's see. And it's wrong. Oh well. I'm right out of time. Again, this will be one that'll be. I need to review it myself. We'll go over this again together. Or what I may do, I don't know. I'll see if I can figure out something else to send to you or the teacher via email rather than video. What I want you to work on is your certification for 7.4. I want that completed by Monday, by the end of day Monday. So if it's not done by class Monday, I want you to have at least gone through practice and worked it through. If you get to these last two problems that I didn't get through, work through the tutorial as need be, and we'll discuss it. But I want you to work on your certification. The plan for this will be to quiz for this on Tuesday. Hope you guys had a great day. See you next week.